Hi, I'm Brock Taylor, Global HPC Solutions Director at AMD. Thrilled to be talking to you and following on to previous conversations we've had at the Hyperion HPC User Forum. So previously, my fellow AMDer Chuck Gilbert had talked to you about AMD EPYC and Instinct processors and architectural improvements, and I wanted to follow on to that talk with some information about workloads running on those product lines. So we know that heterogeneity and the diversity of workloads is growing as developers are targeting specific types of compute units. And so I wanted to really give some information about the different applications that are there and things that AMD is doing to help address the wide range of HPC and AI workloads across all verticals. Now, to start, I want to do a little bit of a recap on AMD EPYC. So, in March of this year, we launched the third generation of AMD EPYC processor, and to date, it's set over 200 world records in performance. That includes a number specifically in high performance computing with 59 application benchmarks, as well as a number in floating point performance and efficiency. All in all, it shows that the AMD EPYC third gen is a really great target for broad use in high performance computing and is really an element that is a basis for many of emerging supercomputers as well, all the way up to exascale later this year. But I want to talk more about the applications themselves and point you to some of those resources. So at the bottom of this page, I actually provide a link to a technical document library that houses many different types of briefs on applications running on AMD processors. Now, within that page, you can actually filter on specific types of applications. So there's a way to go to that page and filter on high performance computing. And that will show you just the common HPC codes that we've been able to write up performance briefs on and show you a lot of information about that particular code. So in each brief, it's going to provide some general information about AMD's third gen EPYC processor, including the range of SKUs that we have and characteristics of each SKU. And in many cases, it will provide suggestions as to which SKU works best or could be best for a given type of application. And then it will go into detailed information of performance of that particular application on a particular SKU of AMD EPYC. So it's a really great set of resources to go and see different performance across different types of HPC workloads, as well as other industries, and then get information on any specific application that we have. Now, that's a space that we continually to add documents. So it's a place you would want to go back to from time to time and see what's the latest information we have. What are the new applications that have been added to that document library? So I want to give an example of a document from that library to show the type of information that are in these documents. And this is one that we recently published around ANSYS Mechanical, where we've seen an exceptional performance boost, not only from using third gen EPYC, but also by using optimizations in the AMD optimized CPU libraries. In particular, AMD and ANSYS collaborated to implement support of the BLISS library that's in AOCL. BLISS is a numerical library for matrix calculations that have optimizations for AMD's EPYC processors. And by implementing support, we saw exceptional speed up across the board. In general, about a 26% speed up of the different workloads. But in one case, we even saw a 2 times speed up over the previous version of code that did not use the optimized libraries. So it's a really good showcase of value that you're getting out of not only just the AMD EPYC processors, but the optimized software that goes with it. So this is an example of a document you can get from that library, and you have different types of applications as well that you can investigate. Now, we also recognize that some of the challenges of getting optimized codes aren't just getting binaries. There's open source codes, and the build from source environment can be challenging to get all the optimizations and meet all the dependencies. So we started an initiative to provide SPAC recipes of common open source applications. SPAC, if you're not familiar, is a a framework for packaging up codes that allows simplification or abstraction of the build process, as well as pulling in all the dependencies that are needed for those optimizations. We're maintaining that on our developer.amd site /SPAC as a way to provide easy means to get access to these optimized applications. And in some cases, the benchmarks or even the tools themselves. So it's a really simplified way to get up and running on some of these codes or get your environment up and running. So I wanted to call that out as a way that you can also go get some of the common open source codes, similar to where you can get information on commercial codes. Now let's talk about AMD Instinct. So last time we talked a little bit about the latest Instinct offering called the MI100 GPU that was launched late last year. Now this is the world's most powerful HPC accelerator, is the first to surpass the 10 teraflop floating point 64-bit performance mark, also includes generational improvements over previous Instincts, and is showing to be a great element for accelerated HPC codes, as well as offering a way to do AI and machine learning. So I want to go into some of the resources that we have available for the AMD Instinct. Recently, we launched an initiative called AMD Infinity Hub. Now, this is a container repository of common open source applications that we've containerized and optimized for AMD Instinct. And so Infinity Hub is a place that's similar to our SPAC recipes. You're able to go and find optimized versions of common codes, quickly and easily pull them and get up and running on AMD Instinct systems. Now, within Infinity Hub, it also points to resources about the developer environment, about the ROCm ecosystem, the software ecosystem, as well as community support and our learning center. Similarly, we recently launched a program called AMD Instinct Education and Research Initiative, or AIER. Now, this is a program aimed at scientists and researchers and educators as a way to help them move their codes and optimize their codes for AMD Instinct. AIER provides resources like access to our tooling, like the developer environments, support forums, but it also even provides resources to help educators and researchers write grant proposals and even procure hardware that they can use in their research. And again, get up and running on AMD Instinct as fast as possible. So at the bottom of this page, amd.com/AIER is the link to find more information about that program, as well as to sign up and get access to some of those resources. So you can see there's a theme talking about applications of both EPYC and Instinct, and that's the software that's used to build them. And AMD supports many open source tools and provides optimizations into those open source tools. In fact, many our own tools are open source as well, and that's our philosophy in development. But we continually provide expanding elements of features in our compilers, profilers, and our libraries, continually optimize in machine learning and AI, and providing the management tools that you need so that you've got access to all the different environments to get the best you can out of AMD and Instinct processors. And so at the bottom of this page, we've got a couple different sites that you can go and find more information. Developer.amd.com will give you a great view of everything we have, as well as for Instinct, amd.com/ROCm. Really provide you the tools you need to get the best out of your codes and really the best out of your AMD investment. So I wanted to wrap up with something that's more on the infrastructure side and something that ties it together. And that's a case study about Northern Data. Northern Data is an infrastructure provider for high performance computing and machine learning. And they really pride themselves on their use of green and renewable energy, with over 90% of their data centers powered by green sources. And they're looking at providing a very cost-effective way to expand the use of machine learning and provide machine learning capabilities to people that have not been able to break into that area yet. So Northern Data has been able to use AMD to lower power consumption roughly 30 to 40% over other cloud platforms, and ultimately translate that into customer value that in some cases they're able to offer the same type of machine learning capabilities at almost half the cost of other cloud platforms. And again, do so at providing this through green data centers and energy efficient, and again, an element of lowering their carbon footprint. So really fitting into their their culture of providing providing compute resources that are high performant but really good for the planet and the environment, and being able to take AMD and really showcase that. So as we talk about workloads and things, it's also being able to run on systems that meet the needs of the different types of customers, from performance all the way down to power consumption. So again, at the bottom, it's a very long URL, but there's a way to go read this this case study, but as well showcase that there are many different ways to combine AMD EPYC and Instinct processors to meet the needs of high performance computing. And so that really wraps up what we wanted to talk about today. And that's, AMD is really committed to leadership in HPC. And again, that's all the way from exascale computing down to small form factor and everyday use of high performance computing. And you can see it in our products with world record holder third generation EPYC, as well as the fastest HPU accelerator and a growing set of applications that are being optimized and ported to AMD infrastructure. So we see broad adoption across the industry. All the major OEMs and integrators support AMD, and it's really a great way to address the needs of high performance computing and actually get work done that changes the world. So really appreciate you taking the time to hear about what we can offer you, and hope to see you in future conferences face to face. Thank you.